Hi, today I'm going to be talking a little bit about a problem I've had with serialization. So we can see here we've got some scenes, and I call this a scenario. So this is my all scenes scenario, and I've got several scenes in it, like the Firefox scene and the game over or game only scene. So when I go to save all this to disk, so I can edit it and we can save the changes. If I just serialize that using .NET, so let's have a look at the manager, just bring that up, and I go to persist config. So I just do a JSON convert serialized object. If I just do that, then you end up with some JSON that looks like this. And it's very big and very difficult to read. And the reason for that, or the main reason for that, is if you see here, we've got something called a sprite, and it's actually serializing the whole Unity structure of a sprite. And that's not what we want, because the user has selected some pre-canned sprites. So all we're really interested in is which sprite they've chosen, not the particulars about that sprite. So if we look at scene view model, we see here that we've got a sprite property, we've got is editing. These are the sorts of things, tile size, these are the sorts of things that I want to potentially store. In fact, I'm not interested in is editing either. So I can just put a JSON ignore on that. I'll stop that being serialized. Now, the problem is how do we keep the sprite property but have a way of representing that isn't the whole of the sprite? There are several choices you could make, but what I thought would be an interesting way of doing this is to say, if you look back on the manager, you see here I'm supplying a converter. And that converter's got some initializers. So we see here it's got a set of available sprites and available colors. And they are basically these two scriptable objects. That contains the array of all the different colors you can have and all the different sprites you can have. So that way, I can pass these in and I know something about what is available. So inside this converter, it does know whether you've got a good sprite or whether you've got a good color or not. And then what happens when you call serialize, it's going to call its override write JSON. And what I do in here is then I look to see whether the thing we're serializing is indeed a scene view model. And if it is, then I can get hold of the sprite property. I can use our available sprites method or component that we just passed in. So the converter has some external dependency that's been injected into it, which is the available sprites. And then I can create a new JSON property called selected sprite index. And then I can remove the existing one. So the thing that has all of that sprite information, I've now removed it from the output and replaced it with a single selected sprite index, which is just going to be an integer. And I do a very similar thing here with the color. So what does that give you? Well, that gives you a result that looks like this. So we've gone from, if we look at this scene called scene, it's a bit unfortunate. You can see all this sprite information. So I've got a sprite here and it is editing, and a sprite, a name called space shooter, and then all that sprite information. Whereas in the actual one, that's all gone now, and it's just been replaced by these simple select indexes. So that makes the JSON much more readable, much easier to save to a cloud service, just generally a lot simpler to manipulate. Now that's only half the story, because if you do this, then obviously when you go to hydrate this, these properties don't exist in the scene view model. So I need some way to convert back from that JSON. And when you create a JSON converter, then you get write JSON, so that's the output, but you also get read JSON, so you get the opposite. Now this one's a little bit harder to understand because this takes the whole stream and you start reading from the stream in a tokenized way. So here we've got a while loop that says keep on reading, and if we find a start object, then create a new C model. If we find an end object token, then return the C model that we've built up so far. And then in between these, we start getting properties. So we can check to see whether we've got our select color index, which doesn't really exist. And if it does find that, then we find the correct Unity color and assign it to here. And in a similar way with a sprite, if it's called selected sprite index, we find the actual Unity sprite and assign the sprite. So we've gone from sprite index property to the actual real sprite property. So that's how I managed to convert from one to the other. The other thing to note about with color as well, just a quick one about that, is you can't serialize the color because it's actually got an infinite loop that's created when it tries to serialize it, so that blows up. So on here you'll notice I put JSON ignore because you can't do it. But with the converter, because when we're writing, we grab hold of the color and we don't write out that color, a Unity color property. We just write out the integer index of which color you've selected. So it gets around those sorts of problems as well. So that's quite neat. So I hope you found that useful. Thanks.